Okay, find the area between two curves. Okay, so if I draw x cubed and 16x, this is kind of the idea of what's happening. So you have a cubic function and a linear function, and you're trying to find the area between them. So that's what's physically happening. Okay, so we have to figure out where do these functions equal each other. So where is x cubed equal to 16x? Okay, if you want to, if your first instinct here is to divide the x out, I don't recommend that because that's going to eliminate one of your possible solutions. So I'm going to move it over instead, and then I'm going to factor. And then I get that these are equivalent to each other at -4, at 0, and at 4. Okay, so you can see that if you had wanted if you thought about doing this, you would have only got 4 and -4, and you wouldn't have gotten that 0 because it would eliminate a solution. Okay, so we have to do these in 2 different chunks. We would have to do the area from 0 to 4. We can't just do the area from -4 to 4. You have to treat this like a chunk and not like a chunk. Okay, so I'm going to do the area under the line from 0 to 4, and I'm going to subtract the area under the cubic function from 0 to 4. Okay, so antiderive from 0 to 4, and then I'm going to antiderive this from 0 to 4. Okay, if I input a 4, if I input a 0, it's just going to be 0. Input a 4, input a 0 is also just going to be 0. Okay, so 8 times 16 is 128 minus 1. Oh, sorry, I did this wrong. There we go. Forgot to, that's not 1 anymore. 4 to the 4th. 64. So 128 minus 64 is 64. So the area under here is 64. Okay, and then I would do the same thing, and I'd go from -4 to 0. And now I would do this region. Okay. With area, you can put them together and do one integral. So from, like as in this piece. Okay, this will come out to the same. You can't go one integral from all the way from -4 to 4, but you can do this. You just have to be careful that if you're subtracting and then this function is a binomial, right, you would have to subtract and then make sure you put that in brackets in case it's a distribution. Okay, I'm not going to do this because I do understand that this is also going to be the same. So my total area is going to come out to be 128. Okay, So a question would be, well, what if I did this in the backwards order? What if I had done this and then subtract that? Okay, well, physically I can see that the area under my line is more than the area under my curve, so that would be the way you would want to subtract it. But it's not going to be wrong. If you do it backwards, you're just going to get a negative answer. And then you just have to absolute it. Okay, it's just like saying 5 minus 2 is 3. And if you do it backwards, you're going to get 2 minus 5, negative 3. Okay, so it is different, but if you did it backwards, just take the absolute value of your result. The area between these curves and this line, so where does this curve equal this line? So I'm going to move everything over. I'm going to factor. So at 6 and at negative 2. So that's what's going on. So we're trying to find that area. Okay, so I'm going to take the area under the line from negative 2 to 6 and subtract. So the whole area under the line from negative 2 to 6. I'm going to take that and then I'm going to subtract that. So you can see that that subtract that kind of idea is what's going to get me what's between. Okay, so the area from negative 2 to 6 under that line, and then I could do these in two separates, but this I could also put together. I could do that. Okay, so anti-derive x squared 2 is 12x. This would have had a cube, therefore I need a 1/3 in the front. Evaluate it from negative 2 to 6. Okay, so I'm going to input a 6 into this whole thing. And then I'm also going to input a negative 2. And I'm going to subtract the two values. Okay, so 2 times 6 squared plus 12 times 6 minus 6 cubed divided by 3. I get 72. And then 2 times 4 minus 24 minus 1/3 times negative 8. Okay, so I have to subtract a negative, and so that will actually add, so I would get 85.333 as my area. Okay, one more. Find the area between these two curves. Okay, so where does this equal this? So again, I'm going to move over, factor, so they equal each other at 0 and at 8. You visually want to see one's a parabola and one's a line that intersect at 0 and at 8. And I'm trying to find the area between. Okay, so I'm going to take the area from 0 to 8 under the line minus the curve. Okay, so anti-derive x squared 4, x cubed 1/3 from 0 to 8. So input an 8. And when I input a 0, I think it's all going to come out to 0. Okay, so 4 times 64 and 8 cubed divided by 3. So my final answer is 85.33.